Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and we are talking about the Artemis program. Hey, Ben, how are you doing?
Hi, I'm fine. Hi, fellow Econauts. Hi, Simon. How's it going?
It's going all right. Um, we talked about the Artemis project in our last episode. It's a part of our mini-series. Last time we talked about the Artemis 1 mission, and today we're talking about Artemis 2. Maybe you can give us a little brief overview about those two missions and what the differences are.
Yeah. So Artemis 1, as we explained last time, was a series of a lot of tests to test that the spacecraft is safe for people, that the procedures work, that the rocket works. Just to give you a brief overview, so the SLS, that's the rocket to boost the Orion, which is the spacecraft attached to the tip of the rocket. And the whole mission was about sending that spacecraft to fly by, close flyby the moon twice, and then come back to Earth. As well, at the same time, the ICPS, which is the extra booster rocket attached directly to the spacecraft Orion, deployed a number of CubeSats along the way. As I mentioned, the whole Artemis 1 mission was there to see that every system works before we actually put people on board. Artemis 2 is now very important because now we will have astronauts on board. They will perform a couple of tests along the way, and they will circumvent the moon like the first time since 50 years, and then come back. And then obviously prepare for Artemis 3, which will then be landing on the moon. So I think that's pretty exciting.
Yeah. So who's actually going to the moon?
So we have 4 astronauts. The commander is Reid Wiseman. The pilot is Victor Glover. The mission specialists are Christina Koch and Jeremy Hansen. We will put a link in the description so that you can read more about them in detail.
We also have a picture on screen right now so that you can see the astronauts in front of the capsule. Is that correct?
Yes, the crew capsule, the crew module. Yeah, that's their little living room, let's say, for the next 10 days when they launch.
There's not a lot of space in that space capsule.
I think it's also quite amazing that, I mean, all the effort we're doing, like the size of the rocket is like it's a large rocket. I mean, if you look at behind me, that's the Saturn V for the Apollo mission, and also here, the whole rocket, and I think you can see the crew module there swimming on the water. The whole rocket to push this little thing to the moon.
That's incredible. All right, so let's take a look at the mission map. You can already tell that it looks a little bit different to the Artemis 1 mission. Maybe you can give us a little overview what the differences are between those two maps.
Yes. First of all, obviously the launch is quite similar. The SLS will push the Orion spacecraft out of orbit with the booster rockets first. They will separate, splash down. The SLS will continue to boost and then separate stage by stage until the spacecraft Orion is only attached to the so-called ICPS.
And the start sequence is basically 1, 2, 3, 4, and until 5, I would say, right?
Yes, yeah, exactly. When we reach 6, so Orion, including the ICPS, have now reached a stable orbit around Earth. What happens now is that there will be a separation between the spacecraft Orion and the ICPS. And at the same time, the crew will now perform a so-called proximity operations demonstration sequence, which also is on this diagram demonstrated on the right-hand side. This is important so that the crew can actually train a maneuver for, when they have to dock later, maybe for when they dock at the gateway or dock with something else. Later on, also when they have to get back from the lunar surface to dock with the spacecraft, the landing module has to dock with the spacecraft. So that's actually quite important part of the mission. And, also a lot of data will be gathered for ground control so that they can see everything works. They can test the maneuverability of the spacecraft. And, it's a very interesting test procedure, really. Also, I think the interesting part here is also that the test will be performed manually. So the crew has to do this. Actually, they only can use the cameras and their, everything they have available to make this happen. Yeah. So from there on, obviously, the ICPS is now separated. Will splash down back on Earth. Orion will make another,
Which is the
another
dotted,
turn.
which is basically the dotted line that we can
Yeah,
see.
exactly.
Yeah.
Yeah, exactly. Yeah. So and then drops down on the far side of Earth from our perspective here. Just one thing, obviously, this is also not to scale. Just to mention that before we get anybody like, yeah, there's more distances, but this gives
Yes,
just
it's
we took this directly
it's
from
a
the NASA side.
little mission map, right?
Yeah,
It's
exactly.
not to
Yeah.
scale. All right. Also, I think also the stars in the background are not a constellation that we are familiar with.
No,
All right. Okay.
definitely not. No.
Let's put the
So
map back on screen.
yeah.
Okay, moving on.
So anyway, once we have done the separation and the testing, and once we got our extra round around Earth, now the spacecraft Orion will perform its transit to the moon. On the way, there will also be a test of a very important part of this mission, and that is the laser communication. So the spacecraft will have a laser communication system on board and will transmit data between the spacecraft and the ground control, which is also very interesting with laser communication. There's a lot more data we can emit between them, and also quite focused. It's not faster in a sense because the light still travels with the speed of light, obviously, like radio waves as well, but you can send more data at once with a higher bit rate. So I think that's quite important. So when the spacecraft reaches the moon, now it will obviously go and circumvent it once. There will be a couple more tests of the astronauts at this stage, but they will not attend a landing. They don't, that's not the part of the mission. That's Artemis 3. And then after the flyby, they will begin their transit back to Earth. And then similar to Artemis 1, the spacecraft, travels back. When it's close enough to Earth, the crew capsule will separate, turn around so that the flat side is facing Earth. There's the heat shield. It will then descend into our atmosphere because of the friction, obviously getting very hot, but also decelerating a lot. And then finally, when it then sort of is close enough, the parachutes will be opened and the crew module will splash down in the water where ships will welcome the crew.
You already mentioned Artemis 3, which is obviously something that we will discuss in more detail in our next episode.
Yes, yes.
But if I'm not mistaken, so everything that we see here in those two missions, Artemis 1 and 2, are in preparation of landing on the surface, obviously. And
exactly, yeah.
And if I'm not mistaken, the first mission was a little bit longer to do a stress test with all the systems, so
Yes.
that it's safer for the crew for the second mission. Is that correct?
Yes. Yeah. So the first mission, the first Artemis part was, I think, was 25 days, if I remember correctly, and Artemis 2 is planned for 10 days. I mean, obviously, one reason is because we only do one round around the moon, also not a close flyby. But yeah, so pretty much it's the minimum amount, let's say, to take. And also, you don't want to put the crew in danger because now it's the first time that Orion will fly with a crew. So obviously, the first time you do this in a short amount of time, not with a long mission, so that you can gather all the information, and then in case there's something which needs to be rectified, you can rectify before you go on with the Artemis 3 mission, where it's critical that everything works, because Artemis 3 will actually attempt a landing, and everything has to work. It's extremely important that you do a stress test and that you test everything as much as possible, really.
Yeah, obviously. I think it's pretty amazing. I also saw on the map that the booster rocket has this time around it's going back to Earth right away, while
Yes, yeah.
in the first mission it actually had a little a little own mission around the moon.
Exactly.
You
Yeah.
mentioned that there were cubes deployed, and then it went into
Yeah.
space.
CubeSats. Yeah.
Yeah. So
Exactly. Yeah.
so what are the cubes about?
So
I
the
forgot to ask you
CubeSats.
last time, so I'm asking you now.
Yeah. Yeah. So maybe just a quick explanation. A CubeSat is just a standard format for small satellites. There, imagine a little cube the size of a slice of bread, and then as a cube. And with the technology nowadays, you can just fill it up with almost anything. I don't know what the 10 CubeSats specifically are about, but I assume there will be like small systems to be tested, maybe remote sensing as well, to take pictures from the moon and just to test that. A lot of universities do that. Here in Western Australia, for example, the Curtin University, they send their own CubeSat with a SpaceX mission, with the Falcon 9, the S.P.I.D.E.R project. But yeah, pretty much they are small research satellites. These days we don't need billion-dollar satellites to do some things. We can sometimes get away with a small CubeSat, and it's the word CubeSat is really just a standard for this size. So every cube you can have also 2Us and so on, and stack them together, make bigger CubeSats out of it.
It's like
And yeah,
Lego.
it's a bit like Lego, yeah.
All right.
It's a standard. So the main reason, maybe that I just in a final edition, the main reason you do that is there's a certain system to deploy them. So you imagine an ejector system which has a specific size, and the CubeSat has to fit in and has to be able to clamp and to this ejector system. This also is stress tested to the get-no. And then at the end, when you eject it, it works with the same mechanism. So it's a standardized way to deploy it, so that you don't have to buy or build a specific deployer for every different satellite. So therefore, the researchers and developers, they can develop one, and pretty much it will work if they keep their design close to how it has to be.
All right. Okay. Very interesting. And again, thank you very much for explaining. Next time we are talking about Artemis 3, and which is, a little bit in the future. Artemis 2, if I'm not mistaken, will take place in November 2023. Is that correct?
Exactly.
Yeah.
Yes.
Okay.
Yes,
Fantastic.
that's correct.
So it's not that far away anymore. So we will
Yeah.
be sitting on the edge of our seats to experience
And then
that.
watch the launch. Absolutely.
And I hope that you enjoyed our show today. If you have, please leave a like, subscribe if you haven't already, and I will see you next time.
And hit the notification bell.
Hit the notification. Okay, and hit the notification bell for just to amuse Dr. Ben the Rocket Man. All right. Okay.
Thanks.
Have a good one. Bye bye.